Okay, can everyone hear me? All right, let's get started. It's 1:30. My name is Travis Elnicki. I am a software architect at a company called Podium. And I primarily, so you think of me as more of a web developer and application developer in my role. And I primarily work with languages like Elixir and JavaScript. Podium is where I work. There's 4 of us here today. We have 2 DBAs and 2 application engineers. We are, like I mentioned, Elixir. We have Elixir as our backend services, and Postgres backs most every one of those. So we're pretty heavy Postgres users. When I started at Podium, we had just gotten into YC, so we're a YC company, and I was the 6th engineer. And today we have around 130 engineers across 3 years, so we've experienced a lot of hyper growth. We went from, I was a 17th employee. We're approaching 700 employees right now. So we've experienced quite a bit of growth, and with that has come a lot of challenges. Podium serves local businesses. So we, our like target market is companies that have a brick and mortar storefront. So you can think of like auto dealerships, dental offices, retail services are all great customers of Podium. And we kind of defined our own space that we call interaction management. And really, like, what that means is we help them aggregate leads into their system, and also, like, in addition to leads, like feedback and their review data, we allow them to communicate internally with their teams. So messaging, there's a lot of internal messaging. And then we also allow them to communicate with their customers. So it's messaging through SMS, Facebook, Google, and our platform provides one space where they can go and do all of those things. We've messaged enough phone numbers now to have covered 1 in 7 phones in the United States, which is pretty big. And this is our product. This is our messenger product, I should say. So this is the tool that allows our users to communicate with their customers. So it's about what you would expect. Today, I'm going to be talking about optimizing query performance from a web developer's perspective. And why I go over all of that information about Podium is I'm actually going to walk you through a specific query and all of the failures along the way that took us to get to where we are today, and all of the learnings that we've covered throughout that process. So my talk is in the form of a storyline. So I'm going to walk you through this story arc. And in order to catch you up to speed, initially I'm going to give you a lot more context, but don't get too hung up on that context. It's not important. What's important is the failures that we find along the way. And the awesome thing about failures is the learnings from those failures, right? So I will make sure the thing to take away from my talk is the learnings, and I will call those out specifically. Yeah, so failure can be good, right? And we'll go through the learnings. So let's wind the clock back to May 4th, 2018. We had a team of 4 engineers and a DBA. And so us 5 total, we're working on what I showed before, the messenger product. And we had just launched, we rolled out the messenger product to all of our customers. And we were working on more additional feature sets. So like feature sets that include like additional filtering or expanding across new channels. But as we were working on our current feature, we had a report from our customer that we had a slow load time. And so for context, we knew already that our messenger product that we had just launched wasn't holding up under our largest customer, but only our largest customer because they're a large anomaly. And we also had communicated with them that they told us that they weren't planning on using it for another 2 quarters. So we're like, okay, no big deal. We'll keep moving forward on our feature set, and we'll come back around to fixing their problem. But this report did not come from that customer. This report came from other customers that were large, but not the size of our largest customers. So there's a little concerning. So we decided to investigate. So, okay, let's jump into the account and figure out how slow is this performing our messenger page for these customers that are reporting it. And so as a first diagnosis, we noticed that it took 5 minutes to return the list of conversations that they needed to look through. And as everyone knows, 5 minutes is a lifetime in web, and nobody will wait for that. So this product became unusable for those customers that were reporting this. And what made it even worse was the query that we needed to show that took 5 minutes was the most meaningful data to represent and the first page that the customer would see. So as they logged in, they immediately got this. So that sucks. As an engineering team, we need to, if we're going to fix this problem together, we need to wrap our heads around the product and get an idea of what's going on. Why is this so complex to render the most recent conversations for our customer? So let's do that. Here's our product again. This is the page that's rendering really slow, and it's this list here. So there's a lot of different pieces to this list. So let me walk you through a bit of all the moving parts so we can fix it. So first, we have this location filter up here. And you can think of a location as a brick and mortar storefront. So as an employee, you could work at many different locations. And so you'll want to change that, and that changes your list. And it basically the phone number that customer is communicating with. Next, we have a little light case management going on here. So we have an open status and a closed status that attaches to what we call a conversation. And as you can see here, the closed is selected. I'm showing all the closed conversations in this list. Next, we're pulling in the contact information related to that customer. And then we have the most recent message that is that either customer, it was either inbound or outbound. That's the last message there. And then you notice there's an unbold and a bold state in this list. The bold means that you haven't read it yet for the user specifically, and the unbold is it's read. And then we paginate the list. So it's an infinite scroll, and as you scroll through this list, it will page 25 at a time. That's what we're dealing with. That's all of the different components visually of this product. So now that we've got our head around what the customer is seeing, now let's go to the tables and get an idea of what the data structures that we're dealing with are at this point in time. First, we have conversations, and a conversation has many conversation items. So a conversation item is a message. You can think of it as a message. Next, we have our one-to-many with conversations and conversation read statuses. The conversation read statuses is what represents the bold and unbold states for our users. Our conversation statuses is a one-to-one, and this is really just the open and closed state for the case management side of things with the conversation. Now, at Podium, we use microservices. And so we have a service, what we just talked about, all those tables, belong together in one database. And then in another application is where the locations live. So those locations, represent the brick and mortar storefront, and we kind of have this cross-service join that's happening here. So we have foreign keys. Locations have many conversations, and the foreign key is on the conversations. And then we have our users. So that's who's logging into Podium and communicating with those customers, right? And users is a many-to-many with locations. And then our last structure that I'll bring into this picture is organizations. So organizations is basically our tenant. So a user belongs to a single organization. Locations belong to a single organization. This is all of the table structures that we'll be working through as we try to fix this 5-minute response time that we're up against. Okay, now we have the product visually. We understand what's going on there. We've looked through high level of the table structures. Now let's see what this query is, and let's step through that. So here's our query. First, we just select from conversations. Then this crazy double join with group by and where clause is what is pulling in our latest message. So the double join is what is helping find what the most recent message is. And the unfortunate thing is this conversation items table is our largest table that we're dealing with. So pretty heavy. We have a left outer join, conversation statuses, that brings in the one-to-one with the open and closed state. Next, we have the conversation read statuses. That is our bold and unbold state that we're bringing in to this select query. This where clause is a soft delete, so we won't be talking about that, but it's there. Here's our cross-service join, basically. We're saying location ID is any number of IDs that we've provided, that we've received from that other service. Lastly, this is where the pagination comes into play. We have our order by publish date descending and our limit for 25 at a time. At this point in time, when we had the slow report, we are dealing on the order of magnitude of 4 million conversations. And conversation items were, I'd say, slightly larger, probably on the order of 60 million. Okay, that's the context. So now let's talk about solving the problem. How should we go about fixing this query? Right now, we are working on a feature, and it would really suck to change context for the entire team and move over to this query. And our product manager really wants this feature out. It's super important. So what should we do? Well, at this point in time, we realized, well, what we could do is we could just pull 2 engineers off the feature. We'll keep this current feature going and in progress, and then we'll focus on fixing this query in isolation. So once we formed that new team, next what we do at Podium when we are faced with unknowns is we do what we call a spike. So a spike is basically you're going to investigate it and dig into the details, and the best case scenario, it's something small and you just fix it and move on, right? Second best case scenario is you have an action plan out of that spike. Like an output of a spike is like, these are the steps we need to do to resolve it. And then like worst case scenario, you have more spikes that come out of your spike. But this case, we spiked and we found a bunch of ID columns that were missing indices throughout our system, not just specifically with those tables that we talked about. So the first thing we did is we just created a migration and threw a bunch of indexes on all of the tables. Some of these aren't even related to what we're talking about, but we saw that they're missing, so we created them. At this point in time, 2 weeks have passed by since our original report of the customer slowness. And as we shipped this new set of indices, we realized it didn't do anything. which was unfortunate. And it took way longer than expected. Our output of after 2 weeks was indices. And that, granted, like that, they had to go through like kind of what I just talked about, with like understanding the problem, diagnosing what's going on, finding those indices, then creating them. But in hindsight, like this is our first learning, and I believe what our first failure was, the split focus really delayed the progress of fixing that query. And in retrospect, a new feature doesn't really hold up to not being able to use the product, right? If you can't log in, it doesn't matter what feature set you can provide. And so what I believe the ideal scenario would have been was to just stop the feature work and really rally the team. Because what ended up happening was it was easy to, like, if that feature needed help, pull those other engineers working on the query back into the feature work. So we take our measurements again after indices, and it's still slow. Literally no effect. So we're still rendering 5 minutes at this point. So we take another step back from the problem. As we were thinking about this, it's pretty clear that the ones that are reporting the slowness are the larger customers. So not our largest, which is much larger than the rest, but bigger organizations. The one thing about our large customers is they have more locations, which is related to that foreign app join, right? So as we were thinking about it, it's like, oh man, that really sucks. I wonder if that like giant like location ID in any statement is really slowing us down. And in addition, wouldn't it be nice if we could just start with a user ID and do all the joins that we need to in one system? So we've been playing around with this new technology called Kafka, and we were pretty excited about it. And so what we did is we decided to stream all of the location data that maps, so basically the many-to-many join table that maps users to locations from that other system into our database. And then from there, we could start with the user ID and go into that location to users table and join it up. So how does that change our query if we're going to bring in those locations? So here's what it was before. The part we're going to affect is just this right here, where this where clause with the location ID is in any. And it changes it to an inner join. That's pretty cool. So let's ship this, and then let's take another measurement. Let's see how we've progressed. And we measure, no change and worse. That sucks. How did that even happen? We really did not understand what was going on. And so we rolled back, we dug into it, and we realized that there's some domain over in that other system, which is the purpose of microservices, right? They encapsulate domain so you don't have to spread it throughout your entire system. And that part of the domain we were missing was archive locations. And so we were bringing over these mappings, and those mappings should not have been shown to the user. And so what actually ended up happening and why it was slower in some cases was we had some organizations that had basically redone all of their locations. So we doubled the amount of locations and the amount of joins that we needed to do for that query. So we rolled it back. And at this point, 6 more days have passed as we're progressing on this problem. And we've learned something else. When we take a table from another system and we directly stream it into our own database, we got the data, but we do not have the code that is sitting on top of that data. And when you start to copy that code, that can become really expensive to maintain, especially with our teams. We are very autonomous in the sense that there's a team that owns all of the conversation data, and then there's a team that owns all the location data. So there's no way, if we start pulling all of their code over, there's no way they're going to know that when they change that behavior, they're going to need to go update it in our system too. So that's where the brittleness came from. And then, again, the domain behavior around the data is what we were missing. So at this point, we've just rolled back what we thought would be our huge win, and we need to do another spike and see what else we could possibly do. We noticed one thing when we spiked. The red status, so the bold and unbold state that is shown in the conversation list, that is an append, basically an append only right now. So anytime a user reads the conversation, we append a new row into that table. And that table started growing really fast. We thought it'd be really cool to have that kind of data and like analyze it and see when users are reading it. But it was kind of just this vision or dream that we had, and we never actually went back to that data and used it in any meaningful way. So it really was just making our query too expensive. So instead of appending, we realized if we just upserted, that would change our left outer join into an inner join. And we can get a little bit more speed from that inner join. So let's do that. So if you remember back to our table structure, this is the table that we're going to be affecting. Here's our query. And if this is the join that we will be changing. So this join will change from this to an inner join. Pretty simple, pretty straightforward, right? So as we take this, we send it to production. Let's see if we have made a difference. So we did. We made a difference. So it's not 5 minutes anymore, it's 3 minutes. But even 3 minutes, that is still a lifetime for web, right? Nobody's going to be waiting around for 3 minutes. So really, we didn't really make much of a difference. 9 more days have passed by at this point. And we hit a total of 29 days of effort. The first thing we did was the indices. That didn't do anything. Then we did the stream of data, and we had to roll that back. Now we've done this upsert, and this upsert is more performant. That's good. But really no significant improvements. We're still up against this battle, and we don't actually know what we need to do to fix it. And the team morally is feeling pretty burnt out and pretty defeated. I mean, 29 days of looking at this same query and iterating on this. And this question came up. We're on Postgres, and we were looking around, and like, maybe Postgres wasn't meant to do this. Maybe Postgres isn't for messaging. Should we be looking at other databases? And that started to sit in the back of our minds as we're iterating through this. But we decided to keep going. We decided to press forward with Postgres because, well, one, migrating to a new database would take forever. And so we had that uphill cost. But the other thing as we were thinking is we realized that double join was extremely expensive. It's our largest table, and it's likely to be a huge culprit in the slowness. So at this point, we had this idea. What if every time we wrote to the conversation item table, what if we had a trigger that then filled another table called last conversation items? And it just did an upsert and maintained the most recent conversation item. So this is what our table structure would look like at this point, with app logic not changing aside from this query, and then this conversations items table just filling in automatically. So here's our query, and this is what we're going to change. This is our double join with our group by. And once we set this trigger table up, we're able to cut it down to this, which is awesome. That's a lot of complexity we just killed and pushed into that other table. So now it's just this right here, this inner join. Last conversation items. Easy. We cut the release for that. We send it to production. We migrated all of our last conversation items into this new table. Let's check how we did. Let's see if it's better. And it is. It was a huge improvement. So 6 seconds to 1 minute was the times that we were seeing on these customers that were reporting the slow load time. However, there's just one problem. We're on the web, and 6 seconds is way too slow for any kind of query, and especially for queries that are the first piece of data you need to see when you log into the platform. That does not look good. That took 3 of our days as we decided to ship that, and now it's, again, back to the drawing board. And at this point, we started thinking, kind of asking why. Like, why is this so expensive? We're only returning 25 rows. That seems like it should be pretty trivial for a database to do. And this was the point we went to the docs, which honestly we probably should have done at the beginning. But we started reading the Postgres docs, and specifically the section about indexes. And they literally have a section on indexes and order by. So I got to this page, and this paragraph, oh man, that's pretty hard to read, but I'll read it. An important special case is order by in combination with limit n. That's us. An explicit sort will have to process all the data to identify the first n rows, but if there is an index matching the order by, the first n rows can be retrieved directly without scanning the remainder at all. The first n rows can be retrieved directly without scanning the remainder at all. That's exactly what we're looking for. Perfect. We were so thrilled. All we have to do is create an index, and we're good. So we did that. At this point, it was, real quick, let me show you what index we created. So let's go back to our order by. Here it is. So order by published date descending, and we have an ID in there now for collisions. Because if you have the same published date, we weren't getting the same sort there. So, and we have the limit 25, right? This is the index we can create. So the doc said, create an index that matches your order by, and then your limit will be able to return early. And what we did here was we created an index that had published date and conversation ID in it, exactly, right? So this time we were testing it out on a test data set, and we were running explain on it. We're getting our best practices. We're getting refined here. And here was our massive explain before we had our index. So huge cost, giant cost, right? After our index, the index shaved 4 orders of magnitude off of our costs. Just unreal. It was so exciting. At this time, it was July 3rd, and it was at night. And it was me and another engineer on our team, and I showed him this. I showed him the explain. We're like, we got to get this out. This is going to be awesome. So we did. And so July 4th, Independence Day, came around. We had the day off, and our system went down. Our entire conversation, nobody had access to it. And so we were working on our holiday, and there's no way. We just created an index. So we spent 2 hours looking at other alternatives, why it's slow, what could be happening. This was the solution. Drop index. Sure enough, it was us, surprisingly. And what was happening was so context. 20 days have passed by at this point. We're on holiday. We had to roll back our index that we shipped late at night. Let me talk about what we learned and what happened with this index. when we created the index on our test database, we only ran the large data set case. And so what happened was, if we go back to the index, publish date and conversation ID, there's no representation of a tenant in that, right? So if you had 0 conversations to return or less than 25 conversations to return, you are looking through that entire index until you hit the bottom to just then return nothing. Extremely slow, and it took down our entire platform. Really great learning, though. Really great learning. Oh, sorry, I'm going the other way. Okay, so if we get back to this, this is our question again. Like, geez, this is not working out. We even used the docs this time. We have had experience with other companies so we're from Utah, for reference, and in our valley, we know of companies that are larger scale than us that use Postgres and are extremely performant. So we had the thought, we should go talk with them. Let's see what they do in order to support the massive scale that they are supporting. So we set up a meeting. We met with a CTO that's across the street from us, and we told them, we have 40 million rows. Queries are taking way too long. This is our table structure. And as we walked him through all of that, he honestly kind of chuckled at us, especially when we was like, 40 million rows, we can't, this is so much data, and they're at like 200 million rows and doing fine. So his advice was to focus on discoverability. I didn't expect that. And then to simplify. He says we were overthinking it. We should take this trigger table that we've created and nix it. We then should take this one-to-one table that just had a Boolean in it and merge it into our conversations table. And now we're left with this. That feels much better. So look at your query, and don't just create indexes. Figure out what your query will need, and then generate your index. And while you're at it, add organization ID to the conversations table. So we've come to the point where we've received a lot of really great advice from our mutual friend that we talked with. And we're ready to simplify. So we're ready to put this in action. So we look back at our query, and if we're going to do what our advice we received, we will be affecting this inner join, this left outer join, and this order by. And now it turns into this. We have one inner join, and that's for our red statuses, so the bold and unbold. And then the next is 4 where clauses, along with our order by, and then our limit. And we get to create an index again, using the same technique that we had learned from the docs, but a little smarter, right? A lot smarter. We have organization ID in there that then will prevent the 0 case or the smaller than 1 page case from scanning the entire table or entire index. And we've approached 21 more days to get this architecture out, this new simplified architecture. And let's see the improvements we made with simplifying. So here is the chart on the day we shipped the new simplified architecture. And you have this point where we've changed, right? So we have these peaks here at 1 second pretty consistently, and then it drops. We're peaking at 300 milliseconds. That's it. We got it. And it's working for all of the use cases. It's working for the zero case and the large case. At Podium, as we release things, we like to look back. We like to take those failures like we walked through and call out those learnings so we can continue to use what we've learned and not repeat our failures. So let's retro, and let's recap the things that we ran into as we iterated across fixing this query. Our first mistake was splitting the team. We really hurt our velocity by not having all of our minds behind this. And it was really easy we were still one team, so it was easy to lean over and say like, hey, can you code review me on this? Could you help me out with this problem? Could you pair for a little bit? And so you're pulling that person out of their context of looking at that query every single time you do that. Then we were taking data from other teams that we did not own, and we did not own the business logic around that data. And so as we were streaming our data in, we had failed to replicate a lot of that behavior. Some queries performed great, but only for specific cases. And this took our service down for a moment, right? Because when we were testing, we only were testing with one case. And so now moving forward, when we're investigating queries, we'll have one that returns less than the limit and another that returns more than the limit. And you're able to compare against those and analyze both of those. Joins, this was as we were with those double joins that we're doing to determine the most recent message. As we killed that, we realized that's what it really enabled us to build those specific indices. And then complexity. Complexity is a hard one to combat as you're moving really fast. But as a principle, we always want to, as we write more code, make it easier to change that code and write more code. So it's a hard thing to combat, but very important. And as we look back and call out what worked really well, the denormalization allowed us to build those indices onto that specific indice. Because we had that, if you remember the one-to-one, we weren't able to include that Boolean in our index when it was in its own table. And targeting specific indices. So as we were just creating indices, just splattering them in our system, it didn't do anything because what we were trying to measure wasn't reading that. And then this order by plus limit optimization, which I, as an application developer, have been working with Postgres quite a lot, but actually did not know that this existed. So, and again, what the optimization is if you have an index that matches exactly what your order by is with your limit, it will return as soon as it hits its limit. And the community. That was the only way we were able to get through this, is reaching out and having another organization help us. And an organization that's gone through similar pain points and has solved them on their own. And so utilizing the community was priceless for us to solve this problem. And discoverability. It's the counter to complexity that we talked about before. As we write more code, we want to make it easier for new engineers to come in and help us maintain the code we write, as well as add more code. And so with this story, I wanted to leave with two morals to it. And the first moral to our story is that failures are okay. And it's important that you learn from your failures so not to repeat them and for you to grow and improve. A lot of companies will say like they celebrate failures. And it's human nature to not celebrate failures. Failures suck. And really what we try to do is not celebrate the failures, but celebrate the learnings. Because that's what's really important. And that's what we pull out of. And then there was a lot of beauty to the solution that we came across. And never in my life have I come across something like this. But solutions can actually be both more discoverable and more performant at the same time. And that was so elegant to me. And as we started solving this problem, you realize the complexity grew and grew and grew. And the complexity was something we kind of just brought on ourselves. We're like, oh yeah, like this is a hard problem. It has to be complex. And so we allowed the trigger table, right? And we had all these other extra tables. But that's not true. You can have both discoverable and performance solutions. So that is my presentation. I really appreciate this opportunity to speak, and I'm really grateful that you all came out to the talk. I'm sure there's things that I'm not aware of in Postgres that would improve what I've spoken about. And if you have any advice or questions for me, please let me know. Thank you.